Hey everyone, let's see this question 23. In it we have given two admissible heuristic functions h1 and h2 for A star search. And now they are creating a new admissible heuristic function with the help of these two h1 and h2 functions. Okay, so first let's know what is an admissible heuristic. So an heuristic is admissible if it never overestimates the true cost. So we are talking about A star search, which is used to find the cost or the path, right? So any heuristic which we will use in A star search, it should be as that it never overestimate the true cost of the path. It should always underestimate. Okay. So if I write this in equation, so this pardon, let's say h star is the true cost, okay, of some n, then h1 of n and h2 of n should be less than or equal to h star of n. This is the condition for h1 and h2 to be admissible. Now we know that these two functions meet this condition, that's why they two are admissible. It is given. Now we need to check that which of these ABCD functions will again satisfy this condition. Okay, so let's see one by one. First option is h1 plus h2. Okay, so we know that h1 is less than equal to h star of n and h2 is h2 of n is less than h star of n, but it is not guaranteed that h1 plus h2 will also be less than or equal to h star of n. For example, let's say your true cost h star is 5, right, and your h1 is 3 and h2 is, let's say, 2, or let's say this is 4 and this is 2. Now independently h1 and h2 are both underestimating the true cost, so these both are admissible. But if you sum these, it will not be admissible anymore, so we can't guarantee that this function will also be admissible, so this option is incorrect. Same goes for second option, that is h1 into h2. Again, it is possible that h1 and h2 independently are admissible or over underestimates the true function, but when you multiply them, it again it will not satisfy this condition. So this is also not correct. Now if we go to the third option, h1 divided by h2. Now in first glance it may look like that, okay, what is wrong with the division? But let's say h2 is less than 1. Okay, so if h2 is less than 1, so let's say h1 is 4 and h2 is 0.5. Now if you do this division, your new heuristic will be h1 divided by h2 will be 4 divided with 0.5, that will be 8, which will be more than your true cost, that is h star, that was 5. So again, this cannot be a admissible heuristic. The last option remains, that is h1 minus h2, and that too modulus of h1 minus h2. So no matter what, let's say 4 and 2 is here, you can do 4 minus 2 or 2 minus 4 or whatever you do, your function will always be limited in by these two values. So whatever your h1 is and whatever your h2 is, if both are positive, this your new heuristic will be bounded by this, something like this. Here it will come h1 minus h2. So this is the, now this is smaller, this is smaller, so obviously because this new heuristic function is coming between these, so this also be smaller, or this also underestimates the true cost. So that's why this option is correct. So h1 modulus of h1 minus h2 can be a admissible heuristic for star. Thank you.